Today I want to talk about three things: reverse engineering, assembly modeling, and error propagation. Please stick with me. So a machine consists of many different components which need to fit together. And if you design a machine inside a CAD software, all these components are part of what is called an assembly. Now, when you 3D scan the components and reverse engineer them, you get a measurement error. And that means that the components inside your CAD assembly don't fit together anymore. So you will need to make adjustments to already reverse engineered components until they fit again. And this is called assembly modeling and can be very challenging, especially with very complex machines. Hi, my name is Svan with HoloCreators, and now let's talk about error propagation. So imagine you have a machine with two parts, component A and B, and they fit together perfectly. So now you make a 3D scan of both parts separately, and your 3D scanner has an accuracy of ±1 millimeter. That means the 3D scan could turn out 1 millimeter bigger or smaller than the actual parts are. So for the sake of argument, let's assume that both parts, A and B, both turn out 1 millimeter too small. So now you have a gap here. In the next step, you make a reverse engineering, a parametric surface reconstruction, which has an error of ±0.25 millimeters. And again, miraculously, both parts turn out 0.25 millimeters too small. So now the gap is getting even bigger. And then finally, you send the parts to production. And you decide on 3D printing. But your 3D printer has an error of ±0.5 millimeters, and both parts again turn out 0.5 millimeters too small. So now at the end, A and B are both 1.75 millimeters smaller than they are in reality. And you have a combined gap of 3.5 millimeters. It's a very extreme example, but you get the point. And this is called error propagation, where from one production process to the next, the error gets bigger and bigger. And that's, especially in assembly modeling, that's a huge issue because you have to compensate all these errors. So how can this be avoided? The solution is to find the production process with the smallest possible error. So for 3D scanning, you might want to go with the CT scanner, the computer tomography scanning, because it has an accuracy of as low as ±0.005 millimeters. And such a great scan also makes a very good reverse engineering and eventually makes the assembly modeling much easier. And finally, production. At the moment, CNC milling is much more accurate than 3D printing. So for very tight-fitting parts, go for milling. Thanks for watching. Have a great day. Please subscribe and see you next time. Bye-bye.